Welcome to this comprehensive guide on pathfinding, a fundamental concept for creating intelligent character movement in game development. Pathfinding is crucial for enabling characters and entities to navigate complex game environments intelligently, finding the optimal route between 2 points. It involves determining the best path while considering various constraints like obstacles, terrain, and other game-specific rules. Today, we'll explore 3 primary methods: the A** algorithm, Unity's nav mesh system, and custom grid-based pathfinding. First, let's delve into the A** algorithm, renowned for its efficiency and versatility in finding the shortest path. A** combines the strengths of breadth-first search and Dijkstra's algorithm, using heuristics to guide its search process effectively. The algorithm maintains 2 lists: an open list for potential best path nodes not yet tried, and a closed list for nodes already visited. For each node, A** calculates an F value, which is the sum of G and H. It then intelligently selects the node with the lowest F value to process next, ensuring an efficient search. Heuristics are crucial for estimating the cost from a current node to the goal, significantly impacting A**'s efficiency. A well-chosen heuristic guarantees finding the shortest path if it never overestimates the true distance. To implement A**, your game environment must be defined as a graph or a grid, providing the structure for the algorithm. The algorithm is then translated into code, where you define the heuristics to estimate cost from any given node to the goal. A** is highly efficient and can handle variable movement costs, making it ideal for diverse and complex environments. It excels at searching in multiple directions and consistently finds the shortest path available. Optimizations for A** include using an effective heuristic function, reducing the graph size, and pre-computing distances. Next, let's explore Unity's built-in solution, Nav Mesh, which simplifies character navigation significantly. Nav Mesh is a polygonal mesh that represents the traversable areas in your game world, dividing them into convex polygons. To set it up, first install the AI navigation package via Unity's package manager. Then, add the Nav Mesh static flag to game objects that represent your walkable geometry. The navigation window allows you to classify objects by area type: walkable, not walkable, or jump. For implementing pathfinding logic, attach the Nav Mesh agent component to your character game object. You can configure the agent's speed, acceleration, and angular speed directly in the inspector. Use agent.setDestination in your C# script to assign a destination for the agent to navigate to. Nav Mesh can be dynamically updated at runtime to reflect changes in the environment, such as moving platforms or opening doors. Adjust obstacle avoidance settings to prevent collisions and promote realistic movement patterns for your characters. Nav Mesh offers a simple and efficient way to set up pathfinding, allowing for dynamic adjustments to paths. However, remember that the agent only works within the defined Nav Mesh areas, and area costs can be adjusted for varied traversal. Finally, let's explore custom grid systems, offering maximum flexibility for unique game requirements. Custom grid systems involve creating a grid that covers your entire game world, where each cell represents a tile on the map. You'll typically create a 2-dimensional array in C# to represent this grid structure. Implement helper methods like getNodeFromPosition, getDistance, and getNeighbors to support your pathfinding code. Pathfinding algorithms, such as A**, can then be implemented to find the shortest path between any 2 points on your custom grid. Custom grid systems provide greater control over the pathfinding process, allowing for highly tailored solutions. They enable the incorporation of specific game mechanics and unique constraints directly into your pathfinding logic. A key consideration is performance, especially in large, complex maps, which can be challenging. Optimization techniques like hierarchical pathfinding and pre-computed navigation meshes can significantly improve performance. Now let's discuss optimizing pathfinding specifically for large, open-world environments. Hierarchical pathfinding is a powerful technique that breaks down vast game worlds into smaller, more manageable sections. This approach allows for faster calculations by first finding a high-level path between regions, then a detailed path within each region. Dynamic pathfinding algorithms are essential for adjusting paths on the fly, adapting to constantly changing conditions. This is vital for games with destructible environments, moving entities, or player-induced changes. Techniques like incremental pathfinding or path replanning ensure smooth and responsive navigation. By understanding and combining these pathfinding methods, beginner game developers can create truly dynamic and engaging gameplay experiences. Whether you choose the precision of a asterisk, the convenience of navmesh, or the control of custom grids, each has its place. Experiment with these techniques to find the best fit for your game's unique design and performance needs. Mastering pathfinding will empower your game characters to navigate intelligently, bringing your virtual worlds to life. Thank you for joining us in this deep dive into pathfinding for game development. Keep creating amazing games.